Hello friends, welcome to our channel Sharpen Maths. Today we will see one linear algebra question which has been asked in Tifr 2024, and this type of another question has been also asked in 2024 in Tifr. So, and if you solve, I will tell, if you solve this type of questions related to linear algebra analysis of NBH and previous year TFR, that will help you to uh, solve question of CSR net exam also. So very near CSR net exam is right. In few days you have to appear in that exam. So whoever are the appearing in this exam, for them I will tell you should think this type of question also. So let's start. If A belongs to M and Q is such that the characteristic polynomial of A is irreducible over Q. Any matrix whose all entries is Q of order n such that characteristic polynomial of this matrix is irreducible over Q. Correct. So here you have to think in which case why any polynomial is irreducible. When we say any polynomial is irreducible, if any polynomial is irreducible, then what will happen? Especially it is saying in over Q, right? Then A is diagonalizable. It will happen. Then it is saying A is diagonalizable in MNC. That is, there is exists P belongs to MNC such that P is invertible and P inverse is diagonal matrix. We know very well. Same, it is related to diagonalizable. If this happens, we say any matrix A is diagonalizable. So you have to check matrix is diagonalizable over C, not Q. Correct. So now we solve this question. First of all, you should think first, then you should watch the video. I will tell. So now come the solution. Matrix has entries rational and characteristic polynomial of A is reducible over Q. It means characteristic polynomial has no any root in suppose char polynomial Pnx has not any root over Q or it can't be factorized in Q. So P and X can't be written as like x minus alpha into PMX, right? If this happen, if any polynomial can be written as product of two non-constant polynomial, then it will be irreducible. But it is saying char polynomial is irreducible, then it means it can't be written in terms of this. It can be written as 2 into x minus alpha into px, something like that. Where, sorry, it like 2 into pmx, where 2 is unit. In terms of product of unit and polynomial can be written in Q. That is called irreducibility over Q, right? So now you can understand easily that it has no any simple root or any repeated root, or it can't be factorized in terms of linear factor over Q. It means it is not diagonizable over Q. It has no any root over Q. It has no any eigenvalue in Q. All eigenvalues belongs to C. If eigenvalues belongs to Q, then it is irreducible. Eigenvalues belongs to Q, it means char polynomial has root in Q, it means it can be written as product of two non-constant polynomial. Then only it has a root in Q, or car polynomial has a root in Q, or eigenvalue in Q. All these things you understood is clearly, right? So it is not diagonalizable over Q. So this question also has been asked related to this, not same, in TFR 2024. So you can see also that question. Now, but it is asking about it is diagonal over C or not. In TFR NBSM, true false question has been asked, and always asked this type of question. So you have to tell it is true or false. Correct. So now come over C. So C complex number is algeb algebraic closed, right? It means the given irreducible polynomial over Q has root, but it belongs to C. Now you have to think all the roots, complex root, whatever be the complex root, that will be the simple or it can be repeated. That is the main point for this question. So it can be simple or repeated. So if you think it is clear that Pnx can be written as x minus alpha into x plus alpha bar into Pmx. Correct. This will happen because it has root in C and complex root always in conjugate pair. If alpha is one complex root in C, uh, uh, then alpha bar also root of this polynomial. So it can be written as this. Now everything uh, till now it is linear factor in a correct polynomial in linear factor. But if you think maybe it has a repeated root, repeated complex root, so then what will happen? If you think this complex is repeated, why we are doing this? You know the result that if manual polynomial has linear factor, then it is diagonalizable. If linear factor has the uh, linear in C, then it is diagonalizable over C. That's why we are trying to proceed in this way. Like, okay, so now think if it has a repeated root, repeated complex root, so then what will happen? It means x minus alpha square can be one factor of this given car polynomial. If x minus alpha square, where alpha belongs to C. If alpha is a repeated root of given car polynomial, then alpha bar is also repeated root for given polynomial. Because why? Because complex root always in conjugate pair. Given polynomial in belongs to Qx, or polynomial in X where every coefficient belongs to Q, then in this case complex root always in conjugate pair. That is fundamental theorem of algebra. I think what this is fundamental theorem, right? So what will happen? X minus alpha bar whole square into Pn. We just break one factor in terms of one factor. Suppose or assume like this. Then what will happen? X x square minus x alpha bar plus alpha x plus alpha bar whole square into pmx. First of all, only we are thinking one repeated for one repeated. If it is not true for one repeated, then no need to proceed further. We can conclude like it has linear factor in C also, right? Polynomial has. So if you solve this, then it is Alpha bar is mod of alpha square. Alpha belongs, and this is real part. If you solve this, then it is alpha bar. If you write, then here some terms will come which is not complex, which is real. You can solve because alpha bar can be written is conjugate. You can think for this example, right? X square plus 1, or backside if you think x plus I, x minus I whole square. Okay, then it will come like this. So similarly, if you take general complex root, then if it has a appear as a repeated root, then these terms will come as a factor of given polynomial. It means now what will happen? If it appear as a repeated root, then this factor will come. Now you think is it irreducible over Q? And now given polynomial have been written in terms of product of two non-constant polynomial because it is also polynomial in Q, right? Every term is a rational number. It's real, right? So that highlights the condition that given chi polynomial is irreducible over Q. That you can say contradict that Pnx is irreducible over Q. It means chi polynomial has linear factor in C, and if chi polynomial has linear factor, then minimal polynomial is equal to chi polynomial, right? You know minimal which is in linear factor. You know if minimal polynomial is in linear factor, then that imply it is diagonizable. One result you know when, okay, where over C, because it is in linear factor over C, not in Q. It means it is diagonalizable over Q. Correct? I think you understand very well. So it is true. So I hope you understand easily, and you can think, you can solve this type of question further. So if you like this video, please like the video, and if you didn't subscribe this channel yet, please subscribe for latest update regarding higher education, everything. Okay, and share to needy one. Don't forget to share. Thank you.